solve these related rate problems. So this one's about oil spilling into the water, and it forms a circle on the surface of the ocean. So the first thing I always do is write down anything that they give me. So it says the radius is increasing at a rate. That's dr dt. That's a rate. The change in the radius, change in time. And you can see the hint. If you look at the units, that's a rate. So that's 3 meters per minute. So that's one thing they gave us. Second thing, keep reading. How fast is the area increasing? That's dA for area over dt. That's a rate. That we don't know. Question mark. Keep reading. When the radius is 5, when r is 5. So those are three things. If you just read the problem and kind of go slowly and look at it, those are the three things that you sort of are given or they're asking you to find. The next step is to come up with some kind of an equation that has to do with the problem. If you read this problem, you look at it, it's definitely clearly about area, and the shape is a circle. So area of a circle is pi r squared. Okay, so that's a static situation for area. And how do you make things change? You take the derivative. So we have dA dt. So that's the derivative of a, dA dt. It's derivative of a with respect to time. So this is basically using implicit differentiation. We're taking the derivative of the letter a with respect to time, so we're going to write dA dt. Okay, next is 2 times pi r, drop the r down to r to the first, but don't forget dr dt. Anytime you take the derivative with respect to a letter that's not time, you got to write dr dt. So that's it. We're at this level. Things are looking good. We've got our derivatives. Now the last stage is to just plug in all the givens from step 1. So this was all step 2. The equation. Step 3 was take the derivative, and step 4 is to plug in everything that we know. So we're going to plug in. Let's see here. dA dt. Okay, we got pi, 2 pi, r is 5, and dr dt is 3. And so now we can do it. 2 times 5 times 3, it's 15 times 2 is 30 pi. That's our dA dt. And the units, because it's area, our meters became meters squared per minute. That is our dA dt. The change in the area with respect to time is 30 pi meters per second.